Now in problem 1, problem 1 we have done, this is like this. A, B, and we have taken like this. We have taken like this. This is D, this is C, this is R, this is R, this is R, this is R. For suppose if you are given like this, then you have reduced this to a Wheatstone bridge. Now if you are given like this in problem, let us see. If you are given like this, then how to do this one? If you look at this one, this carefully, see between AC and A we are having a wire only. We are having only a wire. Therefore, point A should be equals to point C. We are connecting A and C through a wire only. Therefore, point A should be equal to point C. Point A should be equals to point C only. Therefore, A and C are equal. Therefore, this between D and A, or we can say D and C, because A is equal to C. Between D and A or between D and C, we have resistance. We have resistance R. Resistance R. Therefore, this reduces to. This is R. This is R. Okay. This is CR. This is also equivalent to A. This is equivalent to D. D, na? This is equivalent to D. Okay. Now this one. See, because D, A and C are joined by a wire. Similarly, B and D joined by a wire. Therefore, B is equals to D, same point. B is equals to D. B is equals to D, same point. Therefore, D is equal to C. Therefore, between, we can similarly reduce this, bring this B to this side. This is B is equal to D. This is equals to B. A is equal to C. Therefore, this becomes R, R, R. 3 R's are in parallel. Then what we effective? R by N. R by 3 is the effective value. Effective value is 1 by R. Effective is equals to 1 by R plus 1 by R plus 1 by R. That is equal to 3 by R. Therefore, R effective is equals to R by 3 is the effective value of resistance. Okay. This is another model. Okay. How we can get this parallel? See, this combine this A to C, then this turns like this. If there is any confusion, combine A and C same points. Turn this to like this. But turn this like this only. But turn like this. Then we get R here. We are turned like this. Similar turn like this. Join B to D. Then we get 3 R's are in parallel. So that is another method. Next one, let us see another model. Model number 3. Model number 3. Suppose if you are given like this, the resistance R. This is like this. This is 2R. This is 2R. This is small r. This is small r. This is 2R. This is 2R. This is P. And this is Q. And this is 2R. This is 2R. Now R PQ. R PQ how much? What is the equivalent resistance between R PQ? R PQ. We require R PQ. If you look at this one, just to see this. This is like one Wheatstone bridge. This is 2R. This is 2R. This is 2R. This is R. This is R. And this is 2R. Isn't it or not? Therefore 2R by R is equal to 2R by R, P by Q, R by S. Okay, the 2R by 2R is equal to R by R, no problem. 2R by R is equals to R by 2R by R is equals to 2R by R. 2R by 2R is equal to R by R. This is balanced Wheatstone bridge. Therefore, no current flows to this. This can be neglected. This can be neglected. Similarly, this is another Wheatstone bridge. Lower part. Another Wheatstone bridge. R by 2R is equals to R by 2R. Between 2R it is 2R. Okay, this is like this. Lower one is like this. This is R, this is R, this is 2R, this is 2R between 2R. R by 2R is equal to R by 2R. R by R is equal to 2R by R. Neglected, therefore this can be neglected. Now how the circuit becomes now? Circuit becomes, now the circuit becomes like this. This is 2R, 2R, R, R, 2R, 2R. This is P and Q. This is equivalent to 2R in series 2R, 4R. This is 4R. This is 2R. This is 4R. Now 4R in parallel with 4R. 4R parallel with 2R, parallel to 2R, 4R. First take these two are parallel. 4R in parallel with 4R is 2R. 4R in parallel with 4R is equals to 2R. This is equivalent to 2R in parallel with 2 small r PQ. That is equals to 2R into 2R by 2R plus 2R. That is equals to 4RR by 2 into R plus R. 2 gets cancelled. That is equals to 2RR by R plus R. 2RR by R plus R. So this is another model of doing the problem. This is another model. Okay. Now let us see another one. Another model now. Model number 4. Let us see model number 4. I will introduce the mirror method now. I will introduce you the mirror method, model number 4. So if you are given, suppose like this, like this, like this. First calculate the effective between A and B. All are R's. R, 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 R and R. Now I'll do it in two methods. Now as usually the current flows like this. So division of current is same. Division of current at this point is same because all are R's only. Division of current is same in all the resistors because the resistances are same. Therefore, this is zero potential point. This can be taken as a zero potential point. Therefore, just we can remove that one. Therefore, no current flows. Therefore, this can be lifted up because current is dividing equally in all the resistors. Therefore, we can take this one as a zero potential point. Therefore, R, 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 R. This is B and this is A. Now, how can this reduce this one? This can be equivalent to this like this. This will be like this is R, 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 this is R and this is R. This is equivalent to R R plus R, 2R, 2R, this is R, this is we require between these 2 points, so remember A and B. So this is R, this is R, this is again 2R, this is R, this is R, A and B. 2R, R in parallel with 2R, 2R into R by 2R plus R, 2R square by 3R, అంటే 2 by 3R, 2R by 3. So this equivalents to 2R by 3 this is A, this is B, this is 2R, this is R, this is R. Again these three are in series, R, 2R by 3, R, 2R, R, 2R by 3 and R. This is A, this is A, this is B. R plus R, 2R, 2R plus 2R by 3, 2R plus 2R by 3, 8R by 3. This equals to 8R by 3 in parallel with 2R. A and B. 8R by 3 in parallel with 2R. 8R by 3 in parallel with 2R. Therefore, 8R by 3 into 2R by 8R by 3 plus 2R. That is 14R by 16R by 16R by 14R, I think 16R by 14, 16R square by 14R, that is 8R by 7, that is 8R by 7 ohms. Effective is this equals to 8R by 7 ohms. This is one method. So what we have done, the current is splitting equally at this point in all the sections because this is symmetrical circuit. Therefore, this is taken as a zero potential point. Nothing to do with this one. Current is zero. Therefore, lift that point to the upwards. Therefore, this point is taken as a different point. Therefore, these two come. This is equivalent to this one. This is equivalent to this one, and this becomes what do we call this? 2R. Some circuit is shown for you. Now, I will do this in another method. See, I will do this in the another method. Okay, I will do this in the another method. Let us see that one now. Whichever easy, you can follow that one. This is a mirror method. We call this one as a mirror method. I call this one as a mirror method. So, see, if these look at this one, let us split at this point. Let us split the circuit like this. This will be fold this one. Then what happens? This is a mirror type, isn't or not? If you just fold this one, if you spread this, same image as left hand. This is left side image is same as right side image. If you fold this one, okay. Now this is left side image. This is right side image. Now this can be now first calculate left equivalent. Now this will be R. This is R. This is R. This is R, and this is this point. This was divided. Therefore, this becomes R by 2. Mirror. This part was divided. We have divided this one. This is R by 2. This is R by 2. Okay. Join this one because it's mirror part, no? So this R, this R, this R, this R, this R is this R. This is divided this one. This is R by 2. Now this is equivalent to. Now this is equivalent to. Say that is this one and this one like this. This is R by 2 in parallel with R by 2. R by 2 in parallel with R by 2. R by 2 in parallel with these the same points. These you can write. See, this is like this. this is R by 2, this is R, and again this is R, this is R, this is R, R by 2, and this is R. Now R by 2 in parallel with R by 2 in parallel with R is R by 2 into R by 2 plus R. That's equal to R square by 2 into 3R by 2. This becomes R by 3. This becomes equivalent to, this is R by 2 into R square by 2 by 3R, R by 3. This R by, this equals to R by 3, and this is again, this is R, and this is again, this is R. We require this point and this point, isn't or not? Therefore, this is R plus R by 3. R plus R by 3 is R plus R by 3. What is R plus R by 3? 4R by 3 is equals to 4R by 3. 4R by 3 in parallel with R. 4R by 3 in parallel with R. 4R by 3 in parallel with R. So what is 4R in parallel with R? This is R plus R by 3. This is equal to 4R by 3. In parallel with R is 4R by 3 plus R. 7R by 3. Sorry, parallel with R. 4R by 3 parallel with R is 4R by 3 into R by 4R by 3 plus R. That is equals to 4R square by 3 into 7R by 3. That is equals to 4R by 7. That is equals to 4R by 7. 4R by 7. This is effective. Now this is left side. Now what is right side one? For right side one, again same mirror. Right side again mirror image. Mirror image. That is equals to again 4R by 3. Therefore total R is equals to 4R by 3 plus 4R by 3. That is equals to, sorry, 4R by 7. 4R by 7 plus 4R by 7. That is equals to 8R by 7. This is the mirror method in solving the problem. This is the mirror method in solving the problems. Okay, you got this one? This is a mirror type. Therefore, if you draw a bisect this one, then this will be same as this one. Then take it as R by 2 and join this one. Then effective relations between A and Q and B is same. Therefore, A and Q be calculated as, so R by 2 in parallel with R, that in series with R. The effect will be in parallel with R. Calculate like that. Then you will get this solution. In previous case, both are, answer is same. The methods are different. We'll discuss more problems in the next class. Okay.